Hello everybody, welcome to Physical Science today. So, the topic of discussion is stoichiometry. So, a lot of people get stoiched out about this stuff. So this is where you make the big money if you're a chemical engineer. So if you're a chemical engineer, you get paid for determining how much of each chemical you need to produce your products. Okay? If you buy too much, you might be spending $250,000 more than you need to. And then you waste it. So you don't want to waste it. So it's all about figuring out exactly the amount of reactants you need in order to get the amount of products that you're going for. So my question to you to start this off is, what's on a McDonald's cheeseburger?
Fat.
Okay, so we're saying buns, cheeseburger, ketchup, pickles, onions. Okay, so let's just say that I'm going to order, like I'm the restaurant manager, I'm going to order all this stuff. Would I order 1 bucket of buns, 1 bucket of cheese, 1 bucket of burgers, ketchup, pickles, and onions?
No.
Why not? Well, what would you have extra of?
Pickles. Cheese.
Well, you definitely have lots of pickles because there's tons and tons of pickles in a bucket.
Onions.
Cheese, you'd have extra cheese. Onions.
No, you wouldn't.
Ketchup, depending on how much you love ketchup. Burger, buns would be, well, buns would run out first, right?
Buns and burgers sometimes go out the same.
So let's say that all this stuff goes bad if I don't use it. Do I lose a lot of money here?
Yes.
Yeah, so I don't order a bucket of everything. I figure out more specifically what I order of everything. Okay, so how does this work with, chemicals? We're going to start with an easy chemical formula, which is producing water. How do you do that? Liza? Okay, very good. Thank you. It's H2 because it's diatomic plus O2 yields H2O. Is this balanced? No.
No. 2 in front of the H.
Okay, now this, you have to know this. Okay, so far when we've talked about this, we've talked about the law of conservation of what? Mass. And that's in the balanced formulas, which means I have the same amount of stuff here as I do over here. Can't lose it. So, what do the coefficients mean? Well, so far we've been talking about the coefficients mean the number of molecules or the number of atoms, right? But now I'm going to give you a new definition for the coefficients. So, I'll tell you that these coefficients are 2 to 1 to 2. This is called the mole ratio. It is a system. It's the mole ratio. Okay? So do you guys remember what a mole is from first semester?
It's a mole.
Well, let me ask you this. A dozen has how many pieces?
12.
A mole has
24.
6.02 times 10
To the
to the 23rd. Very good.
I'm smart.
That's a lot of pieces. Why do we need such a big number? Well, think of what we're working with here. This stuff is so small, there's never a way you could pick 1, 2, 1,000, 10,000. So we're talking about a mole as like the standard measure of units. Just like a dozen of 12 pieces, a mole has 6.02 times 10 to the 23rd. And we use that because these chemicals are so small. So we need to have a big number to work with. Okay, so we did talk about this before. Remember that number? We did talk about that, right?
Yeah.
We talked about it.
When I said a mole of water would be about a capful of water right here.
Right.
Let me ask you this. If this is the mole ratio, someone read to me in sentence form using moles this chemical equation. Mac.
Mole ratio of water is 2 to 1 to.
Okay. Let me ask you this. The mole ratio of the chemical reaction that produces water between hydrogen gas and oxygen gas is that. How many moles of hydrogen gas do I need to make 2 moles of water? According to this equation. 2, right? Because if I have 2 moles, over here I'm going to end up having 2 moles of water. Does that make sense?
So a mole is basically a coefficient.
Well, in this case, these coefficients is the mole ratio. Yeah. We can talk about that. Let me ask this. How many moles of oxygen gas, Elijah, do I need to make 2 moles of water? Yeah. So if I have 1 mole of oxygen gas, I can get 2 moles of water. So you might say that if I add 2 moles of hydrogen gas to 1 mole of oxygen gas, and it completely reacts, I get 2 moles of water. Does that make sense?
Yeah.
Okay. So all you got to do then is find relationships. Okay? So finding relationships is the first. Well, I'm going to give you steps to. Let's just call this steps to stoichiometry. Okay, so steps. First, you need a balanced chemical equation. A balanced chemical equation. That's the first thing you need. Because that gives you your, what does it give you? Mole ratio. Okay, balanced chemical equation gives you your mole ratio. Number two, this is what you have to do for me. When you get to chemistry class, this will be like second nature to you. But for me, this is what you have to do in the beginning of this chapter. Number 2, you need to write down all relationships. Okay, write down all relationships. Okay, write down all relationships. So now I'm going to define the relationships that you have to write down. Ready? Here they are. First relationship, mole ratio, or ratios. Okay? Okay, so mole ratios. The first one I see is 2 to 1 hydrogen to oxygen. So I'm going to put that. 2 moles of H2 to 1 mole of O2. Okay, is this bringing back some memories?
He's from mole.
Maybe even nightmares, right?
He's from mole.
Oh, I'm sorry, this is the official abbreviation for mole? You just dropped the E. I'm not kidding.
She's
This
the
time.
whole thing. It's just the name.
That's the abbreviation.
You're planning to abbreviate 4
Laughing. Okay, so here's my question. Okay, so I would like to know then another mole ratio. Schneider. What's another mole ratio? Very good, Sam. So it's 1 mole of O2 to 2 moles of H2O. So that's another relationship. Okay? It's another relationship. Right out of the formula. See that?
Wait, scroll down.
Gotta go down.
Okay. You see that?
No.
So is there another relationship? Any other relationship you see?
No.
Yes, yeah.
2 to 1.
Very good.
2
2 to 2 of this, right? 2 hydrogens to 2 waters.
Yeah.
Okay, so let's write that down. So 2 moles of H2 to 2 moles of H2O. Those are the 3 mole ratios. Now, could you simplify these to 1 to 1?
Yeah.
You could. I don't care if you do or not, because it's not going to really change your math at all. So, on your assignment for tomorrow, you're going to have to write down the molar ratios for everything, every question that you have, okay?
Wait, do we have assignment tonight?
No.
Okay, thank you.
Okay, so that's the mole ratio relationship. The next relationship that we need are called molar masses. Do you guys remember molar masses?
No.
Well, we did these before. What is the mass of 1 mole of H2 gas? So the molar masses are going to be always 1 mole, and then you have to do of each little compound in the equation. So 1 mole of H2 is what, Lindsay? Okay, Chris, what's the answer? Very good, 2 grams of H2. That's exactly right. So how do you know that? Look at your molar mass of H. It's 1.00794, right?
Where did this grams come from?
Okay, so this is the cool part about the AM, like the whole number on your periodic chart. If you had your periodic chart, you could see that number.
Awesome.
Look on there, it says 1.00794
Where I didn't even know where.
on the hydrogen.
Where's that? Oh, there.
Okay, is anyone live? The question is, why is moles different than grams? Well, that's because hydrogen only has 1,
Mole, 1 gram.
no, well, it has 1 proton, right?
Yeah.
It only has 1 proton.
Yeah.
Where helium is going to have 2 protons, 2 neutrons, and those are the things that actually have weight. So 1 mole of helium is going to be like 4 times as big as 1 gram. I mean, as one hydrogen.
I think just confused.
Well, look at helium. The helium has the mass unit of 4. Do you see that?
Yeah.
Yes.
So all you do is turn that into grams, and you're done.
So it's
So
8.
oxygen would be 1 mole
Well, hold on.
to over 15 grams O2 or
Okay.
or maybe third.
Okay. So look at your periodic charts and tell me what 1 mole of O2 mass is.
15.
16.00.
30.
Get the
I haven't heard the right answer yet.
It's
15,
30.
14.
16.00.
Okay, but look, it's O2.
32.
32. Anybody wondering how we got that?
You wrote it 16 times by 2.
Now listen to this. On your homework for tomorrow, you need to make sure that all of these labels are here. So you have to have gram and you have to have O2 there. I'll tell you right now, if you take any shortcuts on the labels, you will fail. You're going to fail anyway, that's right. But you'll never succeed until you do it this way. Well, yeah, of course you're going to fail. You're learning something new. Okay. Let's ask Reiner.
Michaela doesn't know.
Reiner. 1 mole of H2O is how many grams? 18 is very correct. 18 grams of H2O. Okay? Please ask questions.
Okay.
Okay. Here's the question I want you to answer. If I have 15.6 grams of H2O, how many grams of O2 did I use? Okay, write that down. Okay, so this is the way to solve stoichiometry problems. So we started with all these. So we're on number 3, okay? So number 3 is, so this is like the third step in solving. Ready? Write known on paper. Yeah, it's gonna work. Just write the known down. Write the known down. I'll show you a little bit. Just write down. Write the known down, and then put relationships in order to factor out the unwanted label. Unwanted label. Otherwise known as stinking. That's another word for unwanted. Factor out the stinking label.
Whoa. That's a lot right.
Okay, write that down. Because I'm going to erase that. So, write down the known. 15.6 Gs of H2O. You need to make sure you have all these labels. Okay, so now look at these relationships. Which one? Now, I'm going to put relationships in. Remember this whole thing?
Oh, wait, I'm right.
So I know I have to have grams of H2O on the bottom because grams of H2O divided by grams of H2O is 1. It factors out.
Okay.
So now I have to look for my relationship that has that. Oh, here it is. I'm going to put that in to my formula. Okay? So 1 mole of H2O is 18 grams of H2O. Do you get it?
No.
So now this factors out. Am I looking for moles of H2O? No.
No.
So now I got to look for a way to factor out moles of H2O. And I need to really get to the whole oxygen thing, right? So now I'm going to use my mole ratios. So look at this. What do I have? Oh, right here. This one. Do you agree?
Sure.
Yeah.
Now I can put these in upside down if I want to. Remember, I can flip them around. But I know that for every 1 mole of O2, my relationship with oxygen, or with H2O, is 2. So it's going to be 2 moles of H2O to 1 mole of H2. Does that cancel out?
I have no clue.
Yes, it does.
Okay.
So what, now do I need moles of H2? No, I want grams of H2. So what has to cancel out down here? What has to go down here again? Moles of H2. So now I'm going to look to the mole mass of H2.
Which is like,
Oh, there it is. 1 mole of H2 is equal to 2 grams, or, wait, how did we go to H2? We meant to O2.
I don't know.
Yeah, this is O2 here. Everybody erase, make that O2. 1 mole of O2. Mole of O2.
What is going on?
What?
Here it is. Do you guys agree?
Sure. Yeah.
No.
Yeah, sure.
Yeah, that's it.
Is that going to cancel out moles of O2?
Yeah, sure.
But I have to flip it upside down, right?
Right.
Was that 1 or 2?
I don't know.
Oh, that's 1. 1 mole of O2 is 32 grams of O2. Does that cancel out?
Yeah.
Am I left with grams of O2?
Yeah.
Yep.
Now I just have to do the math, so get out your calculators, I'll tell you how to push the buttons. Okay, we're back on. So how you do this, the easiest way without messing up, is you go, put in this number first in your calculator. 15.6. Okay, shh. Now look over here. This number 18 is on bottom, so you have to divide.
Yeah.
So push divide, and then push 18, and then push equals. And you should all get, you should all get 0.86667, right?
Yeah, sure.
Okay,
We're not supposed to
so,
create seven.
shh. So we're not, so now we're on this one. Oh, look, this number is underneath, you divide again. Divide by 2, push equals, you should all get 0.43333.
Okay.
Oh, look, this number's on top, so now you have to multiply. So push multiply, push 32, and your answer finally is 13.87 grams of O2. And that's how you do the hardest stoichiometry problem in chemistry.
Wait, what?
Oh, this is the really hard one?
That,
Have fun. Well, it could be just one step harder. I'll tell you that later.